Okay, hi. My name's Henry. I am the Corporate Outreach Officer for CPSec this year, and this is my talk on the CrowdStrike outage. Raise your hand if you've heard of the CrowdStrike outage. Okay, cool, most of you. If you haven't, no worries, I'm going to go over sort of the basics of that. Before we get into that, let's start with, who am I? So, like I said, my name's Henry. Last year I was a fourth year CPE student, now I'm an EE Master's student. I used to enjoy going rock climbing and getting outdoors and doing hiking and all those fun things, and now I sit inside and read papers all day because that master's student life. So that's about me. Oh yeah, and this is my dumb dog Carson with 2 socks in her mouth. So CrowdStrike. In case you live under a rock, on July 19th, CrowdStrike released a patch that caused Windows machines to boot loop. Boot looping is when your computer tries to boot up, encounters an error, shuts off, restarts, tries again, crashes again. Hence the name boot loop, it just loops through. This had a huge impact on all the companies using CrowdStrike, pretty much all of their endpoints, so all of the computers that their actual employees were using, and in some cases their customers were using, started boot looping. And to cap it all off, the fix was very manual, very time consuming. Bunch of major airlines were affected, finance companies were affected, broadcast companies were affected. From personal accounts, I know Amazon was affected, Keysight was affected, that's where I was working this summer. My computer was not affected, but it was running CrowdStrike, so it could have been affected. So, yeah. So, taking a step back, first of all, what the heck is CrowdStrike? So, CrowdStrike is a cybersecurity firm worth $73.5 billion. They developed an endpoint monitoring solution called Falcon. Falcon is basically McAfee, but on steroids for enterprise clients who can afford to pay big bucks for really expensive endpoint monitoring software. So it looks for viruses, basically. It's anti-malware. So, what is Falcon? I kind of went over this already, but it's an agent that runs on your laptops, your desktops. This is primarily used for your employees that use a computer, so pretty much all of your employees most of the time. Just looking for any suspicious activity or programs that could be viruses, malware, worms, any of those fun things. And it either kills them if it notices they're doing something weird, or in some cases it just stops them from running altogether. Like I said, it's basically McAfee. It's the most popular enterprise endpoint protection program with a 24% market share. So a lot of people are running this, hence why it had such a big impact on the tech world when it happened. Okay, let's talk a little bit about how Falcon works. Falcon's a big, complex piece of software, so I don't know how it actually works fully, but this is sort of a summary of what CrowdStrike published that's relevant to this thread. So, template types define what templates. Sorry, let me start over. So, template types define basically what kind of data we're looking for when we're trying to determine if something is a threat. So let's take ransomware as an example. You're trying to figure out if software is a piece of ransomware. What might you look for? What are some characteristics you might look for in that software to tell if it's ransomware or not? Or characteristics of the system while it's running.
If it's encrypting stuff on your hard drive.
If it's encrypting stuff on your hard drive, yeah, that's a pretty big red flag. Anything else? What might you, what system utilization statistics might you see if you're doing a lot of encryption?
Really high CPU usage.
High CPU usage. There's one other one. This isn't a class, I'm not doesn't matter if you don't get it, but in case anybody has any ideas. Okay, the other idea I had was high disk utilization. So those are our sort of 3 criteria. A CPU workload that looks like encryption, high disk utilization, high CPU utilization. So in that case, the template type would be just pulling the disk utilization, CPU utilization, and some metric that defines how much the CPU workload looks like encryption, and then it would pass that to channel files. Channel files are Channel files are essentially instances of templates that tell you whether it's a threat or not. So for example, the template type tells us, okay, we want to look at CPU utilization, disk utilization, and again, that magical criteria, how much does it look like encryption? the channel file tells us what are the thresholds for that. So like what counts as high CPU utilization? Is that 95%, 98%, whatever? Same with disk utilization. How high does that have to be? So yeah, that's kind of the difference between these. To recap, template types tell you what criteria we're looking for. Channel files tell you what is considered suspicious in those criteria. Also, something I want to touch on, this note here, template types are part of Falcon releases. So, thing with the AV space is that constant threats are constantly coming out, and you don't want to have to update your software every single time a new virus comes out, right? You'll be getting updates like all of the time. So what they do instead is they do these releases, these are actual like software releases, and they just define the template types. Template types are like, what kind of threat are you looking for? And then when an actual threat comes out, they release a channel file that says, hey, this is how you characterize this specific threat. This is how you characterize an eternal blue exploit. Or someone give me another really well-known virus. Stuxnet, I don't know. What was it?
WannaCry?
WannaCry, yeah, that's a good one. So, yeah, channel files are more like per threat. The other thing with channel files is that they're not part of releases. They are literally just a file that gets pushed, and you as a business can't say, I don't want channel file updates. They just happen. You can't be like with a lot of software products, you can be behind the first release, so that if there is a problem, other people get screwed and you don't. But with channel files, that's not an option. You get it as soon as it's available, because you want to be protected from the latest threats. I've kind of beat this horse to death by now, but this is sort of a diagram I made of how this works. You get these statistics from the operating system that go in the template type compared with the channel file, and then CrowdStrike decides, is that a good process or does it get to meet the Reaper? Okay, everyone good on sort of how CrowdStrike works at or Falcon works at like a high level? Okay, cool. So what happened? What actually happened? So in February of 2024, CrowdStrike released a new version of the Falcon sensor, version 7.11. Bear in mind, just want to point out, this is February. This was a while ago. This is not close to the actual, like when this bug materialized. And it contained a new template type for detecting IPC-related behavior. IPC is inter-process communication, so it's basically when two programs want to talk to each other, right? They, I guess, found some way of detecting malware based on how it was talking to other malware, pretty much. And the integration code passed 20 arguments, but the template expected 21. So that looked a little bit like this. You have this function, I named this is this malware, and you passed a bunch of arguments, and then the last one is just 0. This could be any value. When you don't pass an argument to a function, it could be anything. It could end up being hex FFF, it could be hex 69420, whatever. In this case, it happened to be hex 0, which is fairly common. So, you have this code, it's getting this hex 0. This is a null pointer, for those familiar with 357. Actually, real quick, who in here's taken OS? Raise your hands. No one? This is going to be a fun talk. Who's taken 357? Okay. Don't worry if you haven't, I'm going to explain this stuff, like pointers and all that. But basically, when you pass 0 as a memory address or a pointer, you're saying there's nothing there. Like, yeah, I'll touch on that later. But basically, the code is passing 20 arguments. It is expecting 21. So the 21st argument could have been like, when it tries to read it, it could get any value. It's just random. Okay. So this 21st argument was just a random pointer. This wasn't caught by tests since they were passing what are called wildcards for the 21st parameter. So basically they were saying for all their test channel files, they're saying, we don't care what this is. Like, it doesn't matter for our like filtering and stuff, we don't determine whether this is a threat, we're not actually looking at this 21st parameter. And so the code had no reason to read the 21st parameter because it didn't care, the test didn't care what it was. So that meant that the issue didn't manifest in production, and it didn't manifest in their test environment. And this went on for months, until July 19th, 2024, when the shit hit the fan. and basically people woke up to a bunch of services being down, a bunch of people at work couldn't use their computers because they were crashing because of CrowdStrike. Everything was blue screen and deathing. It was a bad time. Was anybody affected by this, by the way? I'm just curious, like at work, yeah?
My mom was stuck in India for another day.
Oh, because of the flight cancellations? Yeah, a lot of airlines use CrowdStrike, and they weren't able to operate because of that. You have a question, or?
No, I just had a flight that day.
Oh,
But I
yeah.
still got on the flight, so it was fine.
Was your boarding pass handwritten, or was it like normal?
I was normal.
Interesting,
Yeah, I
okay.
don't know how I got on that flight.
Who are you flying with, if you don't mind me asking?
It was like Hawaiian Airlines or something.
Interesting. Okay. Yeah, most of the big airlines were affected. I don't know about like the smaller ones though.
Yeah, maybe.
And Spirit wasn't.
Spirit wasn't
Spirit
affected.
wasn't affected.
Why Spirit, guys? Moral of the story. Yeah. Oh yeah, and this is another funny thing I wanted to share. Someone, drew over CrowdStrike. Well, this speaks for itself, really. I don't need to explain this. And then one more funny thing I wanted to share is this is Kaspersky's actual. So Kaspersky, for context, is a competitor to CrowdStrike, who makes endpoint protection products. They don't do business in the U.S. because they're a Russian company. But yeah, I like this A because I love it when companies flame each other, and B, the added context of Kaspersky causing machines to crash. Yeah, anyways, that's pretty much all the memes I could find on this. So going back to the timeline, right, 9 p.m. Pacific time, CrowdStrike pushes a new channel file that utilizes the bad 21st parameter. So what happened from the code's perspective is it says, oh, I actually need to check this 21st parameter to see if it's a threat. And it tries to check the 21st parameter, and it tries to dereference a null pointer. We're going to talk more about that later. If you don't know what that means, that's totally fine. But if you try to dereference a null pointer, the system crashes. We're going to get into more technical nerdy detail later, but that's basically, yeah. So all running computers with Falcon installed and downloaded this bad update. Again, there's no way to tell it not to. CrowdStrike will download a channel file whenever it can. So if your computer was on between 9 and 10:30, you're cooked. At 10:30 though, CrowdStrike updated the patch, updated the channel file so that it wouldn't cause computers to crash. But by that point, the patch had been live for an hour and a half and a bunch of computers had already downloaded it. This is a graph from Microsoft of their bug reports over time. You might be able to spot the issue here. So this, as far as I can work out, this is the number of devices that were reporting crashes, and this is the number of actual reports. Because remember, it's boot looping, so it's continually generating crash reports. And then after that, like we said, any computer started boot looping. To remediate this, the user had to boot into safe mode, manually delete the channel file, which, I don't know if you know this, is kind of a lot to ask of the average Joe who just uses their computer to use Chrome. And this is exacerbated by many organizations using BitLocker encryption. For those of you who are blessed enough to have never worked with BitLocker encryption, when you're an individual and you do something weird like boot into safe mode, it'll ask for your BitLocker key, which is really annoying, but it's fine because you log into Microsoft.com and it tells you what your BitLocker key is. If you work for an organization, your organization has the BitLocker key, so you can't log in and get it. And organizations were suddenly met with this issue of they had thousands of BitLocker keys and thousands of employees who couldn't use their computers because of BitLocker. So that was fun and interesting. Now I'm going to talk about some of the technical nerdy stuff. So no one's taken an OS class, so this is going to be a trial by fire for everyone here. If you have questions, please ask them, because this will probably be confusing. Even if your question is just, I don't get it, that's fine. But I do hope you enjoy this, because this is the kind of stuff that I'm really interested in. Okay, so we're going to talk about kernel mode. So this is a mode that the CPU runs in when executing operating system code. This is a physical feature of the CPU. This is not software. This is a physical feature of the CPU where it checks, am I in kernel mode? And if it is in kernel mode, it can do some extra stuff. There's certain instructions that are locked behind kernel mode that can only be running kernel mode because they would let normal programs do some pretty bad stuff. And there's a lot of like memory permission stuff locked behind kernel mode. That means that like Chrome can't see, what's another program? I don't know. Windows is general memory, right? Or like, I don't know, iTunes is memory. Yes, I'm that old. So when it's in this higher privilege mode of kernel mode, the CPU has more access, but it's less able to recover from crashes. So when we're running and this outer ring, first of all, you as a user have never left this outer ring. These are like the rings of privilege. 3 being less privileged, 0 being the most privileged. You can do anything here. You've never left this level 3 ring unless you're an OS developer or a driver developer. Everything happens at ring 3 from your perspective. The stuff that happens at ring 2 is drivers, so that's interfacing with the physical hardware on your system, like your mouse, your keyboard, your game controller, whatever. And then ring 0 is like the operating system itself. This is another diagram, but it's the same idea. You have, this is ring 3, this is your users, this is everything you interact with, and then your applications, and then we're not going to talk about libraries. And then down here would be rings 2 through 0. Yeah, really all you need to know is that ring 0 and rings 1 and 2, they have more privilege, they can do more stuff, they can break more stuff, but there's less ability to recover from an error. So, what's my next slide? Operating systems try to segment programs that are running so they can't access each other's memory, right? And because of that, we can say if Chrome crashes, crazy thing I know, never happens, we can just isolate that to Chrome. We can clean up Chrome's mess, kill it as a program, and then move on. So, kind of what I've been talking about. Why does software crash? If your program's written poorly and has a bug and does something it's not supposed to, the operating says, no, you're not allowed to do that, and kills the program. And because it's sandboxed, it can just do that. There's no, it just destroys the sandbox, basically. It says, okay, no, we're getting rid of this, you're done. We're going to talk about drivers in a sec. Sometimes, though, there's bugs in the operating system. And the operating system isn't sandboxed in the same way that a normal program is. The operating system just runs as one big entity for the most part. And so when there's a bug in the operating system and something bad happens, it doesn't really have a way to respond. Like, it's in a bad state and just doesn't know what to do. And that's where you get blue screens of death. Also this is a Linux kernel panic, which is the exact same thing. Something went wrong in the operating system. The operating system doesn't know what to do, so it just tries to print as much debugging information as it can before it reboots and tries again. As opposed to user programs, where the operating system can just say, hey, you fucked up. I'm gonna turn you off now. You can try again later. Someone from 327, what is this?
When you try to access a memory address that you're not allowed to.
Exactly. What's it called?
A seg fault.
Yes, this is a seg fault. This is what happens when your operating system says, you tried to access memory you're not supposed to. This is what happens when your operating system itself tries to access memory it's not supposed to. Does that make sense? That was kind of rambly, sorry. Cool. All right. Actually, I want to go back to drivers real quick. So this isn't super important that you understand this, but I think it's kind of cool. I think most of us are familiar with the concept of drivers, right? In the context of I have a new Wi-Fi card and it needs drivers, right? We've all heard about this? Cool. So a driver at the end of the day is a piece of the operating system that you can load in so that the OS knows how to talk to whatever device you're trying to talk to. The code in there runs with OS level privileges in kernel space. So you're trusting this code a lot to do the right thing. Because again, if the code doesn't do the right thing, you get one of these. Typically they interface with devices, but a driver doesn't have to interface with the device. It can do pretty much whatever it wants. It's at the OS level. It has almost no limits to what it can do. And that's relevant because guess what CrowdStrike runs as? CrowdStrike runs as a driver. To be more precise, CrowdStrike runs as a driver in ring 0. So that's why it's able to crash your entire system. So moral of the story, CrowdStrike runs at kernel level. for some reasons that we're not going to get into, but basically needs to be able to do some kernel level stuff because some malware operates at the kernel level. And so for that reason it runs at ring 0. And so when the people at CrowdStrike mess up, you get a blue screen of death and your computer boot loops. Oh yeah, and then safe mode. Safe mode is basically a minimalistic version of Windows that doesn't load any of the drivers. This is why you can boot into safe mode without boot looping, is because it doesn't load any of the extraneous stuff, including CrowdStrike, which means that it's less likely to crash if you're having issues. Hence the point of safe mode, and that's why you're able to delete the bad channel file. Okay, let's talk about the effects and aftermath of the CrowdStrike outage, because there's some pretty cool numbers out there, and it's kind of crazy to think of the impact that this actually had. So, first of all, 8.5 million Windows computers were affected, according to Microsoft. 5,000 flights were canceled because all of the Fortune 500 airlines are using CrowdStrike, fun fact. 911 systems were knocked offline in several cities, which is pretty scary when you consider how dependent we are on this software. Hospitals had to postpone some procedures because they couldn't access patient records because the computers used to do that were running CrowdStrike. And some companies are considering moving up their hardware refresh instead of fixing machines. So if you were getting a machine 3 months from now and your computer is boot looping because of CrowdStrike, your company might have just said, we're just going to give you a new computer instead of fixing this one because it's too much hassle to fix this one. Here's some fun figures from an insurance report I was able to find. Some highlights, again, so this is just Fortune 500 companies, I should point out. This is not all companies that were affected. All major airlines, or all Fortune 500 airlines were impacted. 3/4 of banking companies, 3/4 of health companies, 25% overall. And it did a whopping $5.4 billion with a B dollars in damages, just to Fortune 500 companies. So, kind of crazy. And how did CrowdStrike make up for their $5.4 billion mistake? They sent $10 Uber Eats gift cards to affected customers. I don't know who specifically received these. I'm assuming it's people who work in IT, with CrowdStrike. And then they were flagged by Uber as fraud because there were so goddamn many of them. So, yeah. Oh, and also as far as, I haven't seen a lot about this, but as far as I can work out, CrowdStrike is pretty much shielded by their terms and service for actually having to pay for any of the damage that they did. Because their terms of service says if our software crashes, we're not responsible. But don't quote me on that. I just haven't seen anyone going after them yet for money. So, what's next? What is happening? So CrowdStrike released a report, which is my primary source for this presentation, included in which was what they're going to do moving forward. The long and short of it is they are going to, they admitted that their channel files don't go through as much validation as sensor updates, sort of circling back to the original problem. The bug was in the sensor update, but their tests didn't produce the bug, but because they were testing sensor releases, they didn't think they needed to test release. What is it? Forgetting my own terminology. What are they? Channel files. So because they were testing sensor releases, they didn't think they needed to test channel files. The channel file, produced a test case that they hadn't tested for in their release testing, and that meant that everything crashed, basically. So they said they're going to do more testing, specifically on release files, before they actually release them, especially given that you can't opt out of them, you just get them if you're running CrowdStrike. So they're going to increase testing. Microsoft also came out and said some stuff, because some people were blaming Microsoft for this. They also released a really interesting blog post that you should read. And they're working on exposing more kernel APIs for antivirus software. So the reason for this is, at the moment, everything just runs in the kernel, right? CrowdStrike runs inside of the kernel, which is the problem here. So Windows is working on exposing more APIs so that you can access kernel stuff without actually running in the kernel. Because really, at least in my opinion, antivirus shouldn't be running in the kernel. The kernel is for kernel stuff. Also a fun fact I learned is Windows is looking to integrate Rust into its kernel. For those who don't know, Rust is a memory safe language that doesn't let you do stupid shit like this. So yeah, these are my sources. If you are interested, again, the Microsoft blog report is really good, but is really intense. The CrowdStrike report is also really intense, but in a different way. This is a bunch of fun numbers. This is the insurance report that I pulled that showed like how much damage was done. So that's kind of wild. The rest are just kind of articles that I pulled some data from. So yeah.